Temperature is a fundamental property of the material, which implies the degree of hotness and coldness. It's just a measure of kinetic energy of the molecules contained in their body. The higher the kinetic energy, the higher the temperature. There are several scales which can be used to measure the temperature, such as Celsius, Fahrenheit, Kelvin, Rankine, Romer, and many more. But among all these temperature scales, Kelvin is unique because it doesn't have any negative temperature. For example, let's talk about Celsius scale. 0 degrees Celsius, water turns into ice. But in case if something has lower temperature than the ice, then this temperature can go below 0 and show a negative reading. For example, carbon dioxide freezes at much lower temperature than the normal water. That temperature is minus 78.5 degrees Celsius on the Celsius scale. Almost every other scale, such as Fahrenheit, works in a similar way. All of them are able to show a negative reading. But Kelvin scale doesn't have this feature. There is no negative temperature here. But why? One of the most simple explanations for this is that this zero is the absolute zero. Molecular motion completely ceases to exist at this point. And no motion, no temperature. And that's why negative temperature on Kelvin scale doesn't make any sense. Well, that's right, but think about it. If we just wanted to fix a minimum temperature, we could have fixed that on Celsius or Fahrenheit scale. In fact, before Kelvin, we already had that point on Celsius scale. In 18th century, Jacob Charles, a French scientist, found an interesting relation between volume and the temperature of gas. He found that volume of gas directly proportional to its temperature. The higher the temperature, the higher the volume. Further studies revealed that volume of an ideal gas at 0 degrees Celsius changed by an amount of 1 by 273.15 for each degree change in temperature. It means if we decrease the temperature, the volume will decrease. And there will come a point when the volume of gas will become 0. But if something doesn't have volume, then it can't exist. And if something doesn't exist, how can we lower the temperature? And that's why this point where the volume is 0 is taken as is the minimum temperature that can be obtained. When we plot the graph, we get a point minus 273.15 on the Celsius scale and minus 459.67 degree Fahrenheit on the Fahrenheit scale. Now the question is, when we already had such well-established and popular scales, so why did scientists decide to invent a new scale, the Kelvin scale? The reason behind this is the heat engine and some mathematical complications. A heat engine is a device that converts heat energy into mechanical work. For example, steam engine, IC engine of cars, motorcycle, jet engine, refrigerators, all are some sort of heat engines. A simple heat engine consists of two main parts, a reservoir, that is hotter body, and a sink, that is a colder body. As we know, heat always flows from higher temperature to lower temperature. So when heat flows from reservoir to sink, a small part of this heat is converted into mechanical work by some means such as cylinder piston assembly or turbines. Nicolas Sarri-Carnot, a French engineer, gave an interesting formula to calculate the efficiency of this heat engine. Efficiency is defined as work output and the heat supplied. An ideal heat engine will have 100% efficiency. It means it will convert all of the heat into mechanical work. As we can see, if we want to increase the efficiency, we have to increase the temperature of reservoir or decrease the temperature of sink. But no matter how high the temperature of the reservoir, we cannot have 100% efficiency unless the sink temperature is 0. In other words, if we want to achieve 100% efficiency, we have to replace the sink with something that has 0 temperature. Fortunately, on Celsius scale, we have something that has 0 temperature, that is ice. So if we make a heat engine consist of steam and ice, we can achieve 100% efficiency. But when this was done practically, the real efficiency came out to be just 26%. So what went wrong here? We know that the lower the sink temperature, the higher the efficiency. On Celsius scale, we can go below 0. If we replace the sink with dry ice at minus 100 degrees Celsius, the efficiency should increase. But if we try to calculate the efficiency by using equations, we get the efficiency 200%. But how something can have more than 100% efficiency? 200 efficiency means it's creating energy out of nowhere, which is a clear violation of first law of thermodynamics, which states that energy can neither be created or destroyed. We can never have more than 100% efficiency. But every time we use a negative temperature, we will always have the efficiency more than 100%, which is impossible. And that's why we needed a scale with no negative temperature. We already had a very popular Celsius scale, which has the minimum point at minus 273.15 degrees Celsius. This is the absolute zero on the Celsius scale. So instead of making a totally new scale, scientists just decided to rename the Celsius scale. We start from minus 273.15 as absolute zero, and this scale came out to be known as Kelvin scale.